Okay. So good morning, everybody. So as already we are studying power. I think already we derived the formula also, and now we are going to study units. So let us make just revise once again power. So we all knows that power. Before explaining the power, in last class I told you there's so many different examples. So for example, if you take a old man and young man, and I will assign you some work to do them, like you can take carrying water or filling the water tank or something. So definitely we can say who will do the work fastly? Everybody, young man and old man. Who can do? All of you.
Young man, sir.
Big man. So same way if you have taken, as we have taken yesterday's class example, so you have to fill the water tank which is present in our terrace. So now one person will put the motor and another person he only will carry the water with the bucket and will fill it. So if I'll put the motor, so it has been taken around 10 to 15 minutes or hardly 20 minutes to pump the water. But if you have taken a person is carrying and pouring, so that it has taken approximately, we have assumed as 3 hours. So means who is more having more power, a person or motor? Everyone, please
Motors.
motor. So, but both work done by them is what? Same. For example, if I fill the water tank with the motor, it has been taken 15 minutes. So, what is the capacity of the tank? 500 liters. So, capacity of the tank is 500, means its volume. So, if I on the motor, it will take 15 minutes. But if I am carrying myself from ground floor to whatever the floor, first floor or second floor, and if I'm trying to fill the water with mine and my bucket, then it is approximately will take 3 hours for me to fill this tank fully, the same 500 liters. So at last, work done by the motor, the total work done by motor is equals to work done by person. But if you notice, work done is equal, but what is not equal? It is finishing, it is filling the tank fully in 15 minutes, but a person is taking 3 hours. So, time is not equal. Time is not equal. So, that is what we used to call it as power. So, power means how fast or how slow you are completing the given work. So if you are completing the given work very fastly, means quickly or less time, then I can say you are having more powerful. So that is why we will say power P is equals to work done by time. If you have taken, this is the formula for power. So we can take time taken. So P is equals to W by T. This is what the formula we have been done. So a person who can do the more work in less time is more powerful than a person who can do less work in more time. Do you understand, everybody? So if any two persons are taking, one person is taking more time for the same work and another person is taking less time for the same work, then ultimately I can say a person who is taking more time is having less power. That is what we will say rate of doing work. We used to call that what, guys? All of you? Rate of doing work is only called as, please respond. What we used to say is called as,
Power.
so, whenever you will get a rate of doing, please remember it is with respect to time. That is the meaning of that. Now, from this, as we all know, from the beginning we are studying in this chapter, work done by the body is equals to something. What is that, guys? Anybody? Work done by the body is equals to something. Anybody can tell? Please.
Energy.
Energy possessed by the body or energy consumed by the body. So that is what I can say. So in place of work done, as we all know, work done is equals to energy consumed. So I can say power P is equals to, what is the formula will come? All of you? E by T. Yes or no? So this is the another formula, either W by T or E by T. Both are same only. So let me take, this is the equation 1 and this is the equation 2. Both are equal. Work done is equals to energy consumed. So that W by T is equals to U by T, E by T. Is it okay, Danishkar? Mr. Kaushik, understand or not?
Yes, sir.
Yes. So now, yes, Aswin Balaji, is it correct? Mr. Aswin, understand Aswin? Please respond. Now, as we all knows that, we know that, what is the work done formula, Mr. Kaushik? Work done formula. Please respond. Work done is equals to, he will never respond. Anybody, what is the work done formula, ma?
Force into displacement.
Force into
Force into
displacement.
displacement. The formula you don't know, Kaushik, this formula. Work done is equals to force into displacement. So now, as we all know, work done is equals to energy released by the body. So in place of E or W, I will substitute this one. So let me take, this is equation 3. So substitute, Mr. Kaushik, you cannot escape so many days. Remember. So substitute equation 3 in equation 2. Tell me, Kaushik, what will happen? Just substitute. In place of E or W, write this F into S and tell me what will happen. Power P is equals to, if I'm calling you means definitely having some purpose. You must say that is your responsibility. So tell me E is equals to, what will happen? I will write F into S.
F by
F into S divided by T. That is what I can write. So now this formula, I will split and I will write F into S by T. What do you mean by S? S means what?
Distance.
Or displacement. So now distance by time is equals to something. Anybody can tell me? We all know from the first chapter we are studying. What is that?
Speed, sir.
Yes, change in speed we can say. So speed is equals to distance by time. That is what we are studying. So time taken. So in place of speed, sorry, in place of distance by time, I can write speed, or you can take even velocity also. But you can take speed only here. So because there is, it's not a vector quantity. So we will get force into velocity, not speed actually it is. So that is what the formula for power. Power P is equals to force into speed. Please remember another formula. What is the first formula for power? Power P is equals to work done by time. That is the first formula. Or energy by time, energy consumed by time. Both are same. And the second formula, if you replace the work done with the force into displacement, we'll get the second formula for power. So power P is equals to force into speed. Okay, that is what will happen. So now that is why we can say a power is a scalar quantity or vector quantity. All of you, power is a what quantity, guys? Please respond.
Scalar.
Scalar quantity. All of you should remember that. Please write it. Power is a scalar quantity. Means it has only what? What do you mean by scalar quantity? Mitakshri, Abhirami, Arun, respond. Arun, don't be silent and don't simply make me angry. What do you mean by scalar quantity? We all know it has,
Only magnitude.
yes, it has only magnitude, or as Abhirami said, no what? No direction. So what you have to remember. So till here, anyone having any doubt, ask me. Mr. Gokul and Danishkar, you understood, Danishkar? So finally, I have to remember two formulas for power. What is that? Power P is equals to W by T or E by T. Both are same. And second one is P is equals to F into V. That's all. Now, if you understand this, then we will go with the units of power. So this is the most important thing. So even class 10 exactly will come. Nothing will change. Even power formula also won't change. Everything here we are studying as in the form of human strength or animal strength and all. But there class 10th will study electric power. Here power, there electric power. So no other changes we can see that. So now let us write. So as we all know, units of power. So what is the formula of power, Mr. Kaushik? First formula, please respond. Power P is equals to. Yes, please.
W by T, sir.
Work done by time. You should not say W by T. You must say work done by time. Do you understand, everybody? So, if you have taken SI unit of power, all of you observe, write it. So, unit of power is equals to something. What is that, Hari? Units of work done or energy. So, what is the unit of work done? Anybody can tell me? You all knows that. Yes, please. Unit of work done. Everybody, SI unit of work
Newton.
done. SI unit of work done, please.
Joules, sir.
Newton.
Joule, Hari. Newton is not Newton meter. Newton meter is equals to joule. That is what we are studying in the formula. Yes or no, Hari? Don't get
Yes,
confused.
sir.
SI unit is joules only, Hari. In place of joule, we can write what, Hari? Newton meter. Understand, Hari? Please
Yes, sir.
remember that. So that is what the formula will come. So units of power, all of you remember units of power. The SI unit of power we people will say is watt. What is the SI unit of power? Everybody, please respond. Watt. Okay. So which will represent with the capital W. Now what is the SI unit of work done? Everyone, please. SI unit of work done. Joule. And what is the SI unit of time? Anyone?
Yes.
SI unit of time. Second.
Second, sir.
Okay. So that is what units of power. So what is the SI unit of power, everybody? SI unit of power is watt. Clear, everyone? All of you? Sanjay, Abhirami, Aswin, please
Yes,
call
sir.
to Omar. Somebody of you call to Omar. That is what you have to remember it. Now, if I will say 1 watt is the power, so means in the sense of, you must tell me, Mitakshri, tell me, what do you mean by joules and seconds? How many joules energy per how many seconds? Everybody.
1 joule energy per 1
joule
second, sir.
1 joule of energy per how many seconds?
1 second.
1 second.
So, if any body will consume 1 joule of energy per 1 second, or if any body will do 1 joule of work done per 1 second, then I can say, what is the power of the body? Everybody? What is the power of the body? Yes, please. 1 watt. That is what you have to remember. The most important one, right? The power of a body is said to be 1 watt. Understand, Harish? Aklan?
Yes, sir.
Yeah. So please write. The power of a body is said to be 1 watt if it does how much work done, Mr. Kaushik? Arun, how much work done? If it does 1 joule of work, or how much energy it will consume, Abrami? It will consume
1 joule
1 joule of what?
energy.
1 joule of energy in how many seconds, Gokul? In 1 second. So that is what we used to call as 1 watt. Anybody is having any doubt? You can ask me. Clear, everybody? Yes, please. So what is the SI unit of power, everybody? SI unit of power is
Watt.
okay. So watt means joule per second. That is what you people can write. Now, bigger units of power, all of you keep reading. Bigger units of power. Bigger units of power. Okay. First one, kilowatt. Kilowatt. Okay. Next, megawatt and gigawatt. So these are the bigger units of power. Okay. So let us write the relation. Now tell me 1 kilo equals to how many grams, guys? All of you.
1000
1,000.
grams.
Mr. Aswin Balaji, open your mouth. I want the response. You cannot be like this so many days. I'm saying you keep on. 1 kilo equals to how many grams? 1000 grams. Same way, 1 kilowatt is equals to, please all of you write. 1 kilowatt is equals to 1000 watts. Is it okay, everyone? So I can represent, remember my notation, small k, capital W. That is what the notation of kilowatt is equals to 1000 in the form of powers. Can you tell me 1000 in the form of powers, Mr. Akilan? 10 power.
10 power 3, sir.
10 power 3 watts. Please remember, 1000 means I can write 10 into 10 into 10. So which is equals to 10 power 3. I don't think so. Nobody of you knows that. Everyone knows, I think. Next. Any doubt? Next one. All of you write. So 1 kilowatt is equals to 10 power 3 watts. Next. 1 megawatt. Megawatt, both capital letters. Notation is very important. Even class 10th, you will get it. Notation is very important, Amma. Kilowatt, small k, capital W. Megawatt, both are capital. Okay. 1 megawatt is equals to 10 lakh. Moon zero, moon zero. 10 lakh watts. So can you tell me in the form of powers, Mr. Kaushik, fastly? 1000, 10 power 3, 10 lakh. How we can write? Around
10 power 6.
10 power 6 watts. Very good. I know you people can speak, but I don't know why you people cannot. So write it. Next, gigawatt. Gigawatt. GW. Gigawatt. 1 GW. Gigawatt is equals to, remember, 9 zeros means 100 crores. You can get it, I think, approximately 3 zeros, 3 zeros, and 3 zeros. Watts. So tell me, what will happen? 10 power, Aswin? 10 power, 9 watts. So this is what will happen. So these are the bigger units of power. So what is the SI unit of power? Everybody? Watts. And bigger units is kilowatts, megawatts, and gigawatts. Anyone having anything doubt, you please kindly ask. If not, I will go to the next one. Clear? Completed? Gokul, Akilan? Now what I'm going to say is most important one, which is very important in our daily life. If now itself you can see, go on, you can see in front of your home or inside your home, you might be having the electric motor. I think most of your houses are having electric motor to pump the water to your terrace or roof. Is it true or not? I want the response. All of you?
Yes, sir.
Yes. So definitely you might be having. Okay. Now, that is what we will say practical unit of power. So let us discuss in our daily life. Have you heard it from your childhood? You think very carefully and check it. Have you heard a word called as this? My motor power is 10 watts, 20 watts, 30 watts, or 1000 watts, like that. Or is there any other word are you using to represent the engine capacity or engine everything. You might be heard your car is like 100 cc, 200 cc, 300 cc, like that you are speaking. Have you heard it? Bike also 160 cc. Yes, please. Engine capacity. Have you heard it or not? Yes, please.
Yes, sir.
Yeah, you might be notice your father is speaking or your brothers are speaking. CC, engine capacity, you might be asking. Yes, please.
Yes, sir.
So that is what, let us discuss what is that commercial unit, or we can say practical unit of power. So motors also in our home. Have you heard a word called as, your parents used to speak half HP motor, 1 HP motor. Of course, Harish might be no agriculture. 2 HP motor, 5 HP motor, like that used to speak father. Have you heard? All of you? Even
Yes,
in
sir.
your home also you might be having 1 HP motor or 2 HP motor, like that. Have you heard, guys? Mitakshri?
Yes, sir.
Yes. So that is what the commercial unit of power. So let us take, we can say commercial or practical unit, means which we are using in our daily life. Practical unit of power, very, very important one, which is having a lot of applications in our daily life. So, all of you remember power of electric motors, power of missions, power of engines, etc. We used to measure in, not in megawatts or gigawatts or watts. We used to measure in horsepower. Do you understand, everybody? So that is only will represent with the HP. So horsepower is the practical unit of power. So if you have taken electric motors, if you have taken any kind of big missions like cranes and all, and you can take engines, all these things will represent power with the help of what? HP, horsepower. So this is the practical unit, or we can say commercial unit of power. Is it okay, guys? Everybody? So now, if you have taken 1 horsepower is equals to, sir, how many watts? All of you remember, 746 watts is equals to how many? How many horsepowers? Yes, please. 1 horsepower. So that is what you have to remember it. Now, if you comes to the nowadays, present days, you might be traveling, so many of you, in trains and all. Have you all traveled train, traveling, bus and all, etc.? Everybody? Present, nowadays. So you might be remember, they will used to represent above the engine. If you notice it little carefully, they will be right. The power of the engine is in the form of BHP, power of an engine. Next time when you are traveling, or you can notice it in the engines, they will, even if you buy a bike, they will give the BHP of the power. You might be find in my bike, for the front wheel they have been sticking. Power of engine is measured, nowadays it is, instead of HP, we will say B dot H dot P. BHP means, that is only called as brake horsepower. Please, all of you remember. Brake horsepower. So it is the unit of power equals to 1 HP. Remember, if I'll say 1 BHP, which is equals to how many HPs? 1 HP. Both are same, Amma. Understand, Mitakshri? 1 HP is equals to 1 BHP.
Yes, sir.
Both are not different. Both are same only. 1 BHP is equals to 1 HP. Nowadays, we'll use this term, brake horsepower. So, which is used in expressing the power of the engine. Okay. So now, more BHP, more powerful, less BHP, less powerful. That is what you have to remember. So if I'll say, for example, let me take a random value, 2568 or something, you can take 2680. bhp, if I take, understanding, while the power of, if I've taken, this is more than if you take normal power, if you take Maruti car, those who are having, basically, if you take a power of a rail engine or electric train, this is what basically 2500 bhp is minimum. If you take Maruti Alto car, Maruti Suzuki and all, you might be getting 800 cc. Have you heard Maruti 800? Have you heard this car? Maruti 800. So what is the, only 37 BHPs. So see the difference. Normal electric trains, the BHP is 2500 above, and Maruti 800, you will get it 37 BHP just. So that is the difference. So who is more powerful, electric train or Maruti car? Yes, please. Electric train, because the BHP engine is more. So that is what is the commercial unit. Are you understand everybody? Clear, guys? Doubt? Please ask. Yes or no? All of you? Now,
Sir,
yes, please ask.
sir, that means the friction of the Maruti is very less.
Friction of the Maruti, not the pulling capacity, nor like power in the sense of load. For example, say nor one motor, suppose I will take one BHP motor, nor one BHP motor and 5 BHP motor. Now, if I'll ask to fill the 500-liter tank, understand, nor I will
Yes,
take
sir.
I'll ask you to fill the tank, 500 liters tank. Now 1 BHP will take 10 minutes, means 5 BHP will take not even 2 minutes time. Within that it will be, because here power is more, so that more fastly it will deliver. So that is what it is. So as we know, railway Maruti car hardly how many members can travel? 5 members. But
Yes,
electric
sir.
train how many? Minimum 1,000, 1,500 members we can travel. So that, so power must be more, correct.
Yes, sir.
That's all it is. So carrying capacity or loading capacity it is. That's all. Nothing is there. Understand?
Yes, sir.
Yeah. So if engine is more powerful, and also you can take one more thing. Suppose if you take Maruti 800 and Maruti Alto. So now Maruti Alto can having a little bit more power than Maruti 800. Means gaining the speed and losing the speed. You might be noticed nowadays all the bikes, cars and all fastly rising, fastly falling. Speed can be controlled very fastly. Have you noticed it? That is based upon the power of the engine. Okay. So if the power of the engine is increases, so that alteration of the speeds can be very faster. So that is what is the advantage of high power engines. Okay. The work done by them is very faster compared to them. And they can carry the loads also. If you take heavy loads also, loads can be carried more. That is what is the difference. Okay, Noor?
Yes, sir.
Yes. So now observe very carefully, all of you. Now, if you'll understand this one, this is the commercial unit of power. And is there anybody is having anything doubt? Practical unit or commercial unit of power? Are you clear, everybody? Yes. So what is the practical unit of power? All of you? Please respond. What is the practical unit of power?
HP.
Horsepower. Or BHP, brake horsepower. Now, same way, the most important one, which is mentioned in our textbook, that is what? Commercial unit of energy. Please write. Now you understand, Hari, why I not taught there? Commercial unit of energy. You will get it now. So basically, this I should teach after teaching the energy. So like, what is the unit of energy? Everybody should tell me. Energy unit. Unit of energy, we all know. SI unit of energy. Joules only. So after immediately I should teach commercial unit of energy, but you may be not understand unless you understand the power. So that is what I have not taught. Now you will understand very easily. Now tell me, we know power and energy, we're having one formula. Just now we studied. We know energy is equals to work done and work done is equals to energy. So can you tell me the formula between power and energy? Everybody, please. Power P is equals to, fastly.
Energy by time.
Energy by time. Very good. From that, can you tell me, Abhirami, energy is equals to what is the formula? Energy is equals to
Power into
power
time.
into time. Purima, எல்லாமே clear? Now, if I have taken here, I'm saying you observe all of you, when I have taken watt, power unit is watt. Remember, time must be taken in seconds. If I have taken power unit in kilowatt, time must be taken in hours. Is it okay, guys? Will you remember this? Harish, Kaushik, Arun, Akilan,
Sir.
all of you remember. When I taken the power in watt, time must be in what, guys? Seconds. If I have taken power in kilowatt, remember kilowatt, small k, capital W. Then time must be taken in what, guys? Yes, please. Hours.
Hour.
That is what you have to remember. Now, from this, can you tell me what is the energy formula? Energy is equals to what? You should tell me. Energy is equals to what?
Power into time.
Power into time. Now, power unit of power is kilowatt. I am taking small k, capital W, kilowatt into, as I told you, if I'll take power unit is kilowatt, time must be in what, guys?
Hours.
Yes, please, all of you. So let me write full form.
Hours.
What I have to take, guys? Everybody. So this is kilowatt, and I will represent with the small k, capital W, into time must be in hours. Okay, hours will represent only with the H. So if I'll write, so what is the unit? All of you, unit of energy, commercial unit of energy, you might be understand by this time. What is that, Harish? Kilowatt hours. Clear? All of you? Yes, please. Respond here. Okay, guys.
Yes, sir.
Yes, yes.
Now, do one thing, take 1 minute just break and ask your mother or father and you tell me what is the electric bill of like how much electric, how many, they will say that you ask them what is the electric bill of your house in last month and what is the power consumption by your house. Just ask them. Your all parents are educated. What they will say, you just listen and tell me. Just fastly, everybody. If they are near to you, you can ask. Also, if they are little far, also go and ask them and say, what is the power consumption of your house and what is the electric bill? Just for any one of you at least. Yes, please. Have you asked anyone? Anybody? If you already, the plus please. Harish, have you asked? Akilan, Danishkar, nobody. Okay. So when we see that, if you ask your parents, they will say last month power consumption of our house or electricity consumption is, they'll say like, have you heard it, like 50 units, 100 units, 150 units. Even Tamil Nadu government can give the free concession of electricity up to 100 units. Is it right or wrong? Have you heard this scheme? Government scheme, 100 units electricity is be free, like that they'll give. Is it yes or no?
Yes, sir.
Yes. What they said, any parent, they told you, my electricity consumption is 50 units, 100 units, 200 units, like that. Now, have you heard it? Your parents are saying? No? So, okay. So, they remember that the most common unit which we'll use for power, electricity power is unit. So, unit means 1 kilowatt hour is equals to, we will say, 1 unit. That is what you have to remember. A general language, we will say unit is the common one for electricity consumption means electrical energy. What is the electrical energy consumed by our house for 1 month? That is what electric bill they will give. Okay, electricity department. So we will say in the form of units. If I'll say my house is consumed 50 units, means in the sense of how many kilowatt hours have been consumed. My house is consumed how much power, guys? 50 kilowatt hours power. If I'll say 100 units, 100 kilowatt hour power. That is the meaning of units. So 1 unit is equals to 1 kilowatt hour. Sir, what is this? If I'm saying my house is consuming 50 kilowatt hour, means what? So if I operate, for example, let me take 1 kilowatt hour. What do you mean by that? Meeting is going to end. Please come back and I will say you. What do you mean by 1 kilowatt hour? So that you will understand what is 50 kilowatt hour. Write it. First, 1 kilowatt hour. Right. 1 kilowatt hour is the 1 kilowatt hour. 1 kilowatt hour is the amount of energy consumed by an electrical appliance of electrical appliance of power 1 kilowatt when used for